not everyone's chronological age and biological age always match up. So, for example, somebody could be chronologically age 40, but then when we measure their biological age, they may be more like age 50.
If you want to live like you matter, ditch the pills, look great, and feel freaking amazing, you're in the right place. I'm Dr. Wendy Trudeau.
And I'm Dr. Ed Levitan. Welcome to the Feel Freaking Amazing podcast,
where we empower you to live a vibrant and healthy life by optimizing your structural, chemical, emotional, social, and spiritual lives.
Hold on to your hats.
Hello, and welcome back to the Feel Freaking Amazing podcast. I'm Dr. Wendy Trudeau. Ed can't be here today, and he's going to miss out because we have Dr. Nichola Conlon here. She is a molecular biologist who specializes in the study of cellular aging and the science of aging well. She helps people reverse their biological age and improve their health span. Her work has led to the development of a dietary supplement clinically proven to reverse biological age. Welcome, Nichola. It's great to have you here.
Hi, Wendy. Thank you so much for inviting me. It's a pleasure.
My pleasure. So, we all want to live well and live forever, but can we actually reverse aging? Like, is that something you've seen?
Yeah, it is. So my background, interestingly, was in drug development. And initially I worked on cancer therapy. And then one day, this was about 10 years ago, my boss came to me and said, Nichola, we're moving you off that project and we're going to put you on a project to develop drugs to slow aging. And I was like, what? Like, this sounds crazy. Is this even a thing? And from that point, I had an amazing opportunity to basically really dive deep into the world of longevity and really understand all of the science that was happening in the space, and to understand, which was a bit, out there, which was things that were actually had good science, that was strong and good evidence, and basically look at the whole field and decide, is there an opportunity here? And should we be pursuing it? And from that point on, I was absolutely fascinated by aging. I was like, this is absolutely the future. This science is incredible. We know that aging is our biggest risk factor for pretty much every major disease that we're suffering from, worse than any of the other risk factors that we commonly know that we should or shouldn't be doing. And if we can slow cellular aging just a little bit, there's this idea that we can, reduce the onset of many age-related diseases in one go. And over the last decade, I've definitely seen a huge amount of evidence, firstly in cells, then in animals, and now even in humans, that actually reversing aging at the cellular level and reversing our biological age is actually possible.
So what is biological age then?
Yeah, so what many people don't realize is that they have two ages. You've got your chronological age, which is simply the number of years since you've been born, the number of candles on your birthday cake. But then you've got your biological age, and this is arguably the much more important one, because this is the rate at which you are aging inside at the cellular level. And your biological age is a much more accurate predictor of your future health than your chronological age. So I could literally take a sample of your blood and look at your cells, and I can measure your biological age. There's a number of ways of doing this. But essentially, the really interesting thing is that not everyone's chronological age and biological age always match up. So, for example, somebody could be chronologically age 40, but then when we measure their biological age, they may be more like age 50. And that would be a bad thing, because it would be showing that they're aging faster than they should be. On the flip side, it could be the opposite way around, and they could be aging slower. And the reason that biological age was so interesting in the longevity field was for two reasons, because it basically proved two really important points. The first thing it showed us is that you can actually measure aging, which for a long time everyone was like, well, it's really cool that everyone's saying we can reverse aging, but how on earth do you measure this? So it solved that problem. The second thing it answered was this idea that everyone believed for a long time that aging was this fixed process, this thing that was like programmed into our cells, into our bodies. But if it was programmed, then our chronological age and our biological age should always be the same, but they're not. And this shows us there's something going on to either speed it up or slow it down.
Okay, so can we drill into this a little bit more? So when I'm assuming there's a whole bunch of markers that you're looking at for biological age. Can you talk about the actual markers that you're looking at? And I know I've had my biological age done from some of the companies that do mitochondrial and telomere health, but what are you actually looking at when you're looking at biological age? What are the components that go into it?
Yeah, so there's multiple different ways of testing it. And I think the general consensus now is that using a range of different markers is the best way to do it. But the most common ones, or I guess the most famous ones, there's three. The first one is one that you just mentioned. It's looking at the length of your telomeres. So your telomeres are little caps on the end of your DNA that prevent your DNA from unraveling, essentially, a bit like the caps on the ends of shoelaces. And as your telomeres get shorter, that it basically is a hallmark of aging. It's something that is showing us that you are aging. So for a long time, this was the only way that people kind of estimated age, was by looking at telomere length. But it's since been found that that's not a very accurate way to measure biological age, because the results kind of depends on where the cells have come from that you measure it in. And we know that in some cells, our telomeres just naturally get shorter quicker than in other cells. So it was more of a reflection of whatever particular body part or organ that you measured it in, rather than aging across the whole body. So the next popular way was something called epigenetic age testing. And this works in a bit of a different way. This is looking at the patterns of genes that you have switched on or off in your cells. So every cell in our body has the same set of DNA, but a cell acts in the way it does, or, a hair cell becomes a hair cell, a liver cell becomes a liver cell, depending on what pattern of these genes they have switched on. Now, generally, as we get older, the pattern of genes in all of our cells that are switched on seems to change. So if I was to look at the cells from a young person, they'd have a very particular pattern of genes switched on that were associated with a young, healthy cell. If I looked at an older person, they'd have a different pattern. And this is called epigenetic drift. So over the years, the pattern of our genes drifts into this different pattern. And basically, by measuring the pattern, you can predict the age.
So can I just clarify that? So you're looking at what wasn't turned on and now what is turned on or expressing itself, and that
on and off. Yeah. Some
Okay.
things. So as when we're younger, some things are on, some things are off, and this can flip and be the opposite when we're older. But generally, if you look at the pattern of genes, when you're young, they're all genes that are involved in lowering inflammation, promoting repair, promoting cellular health. Then these seem to get turned down as we get older, and genes that are actually promoting inflammation and turning down repair processes are switched on. So we see this shift, and using the measure of this shift is the way that this biological age is estimated, using this epigenetic reading. The final way, and the one that I quite like personally, is something called glycan age. And this is slightly different. It's a very similar concept in that we get a change in a pattern. But this time, rather than looking at genes, it's actually looking at what are called glycans, which are like little sugar molecules that are attached to our immune cells. And again, it's the very same principle in that when we're young, we have a very specific pattern. And then as we get older, this pattern gradually changes until you have an old cell and it looks very, very different. And there's big studies linking the patterns with particular ages and also particular diseases. And this, again, is another way to estimate biological age.
So in people who have inappropriately old biological age compared to their chronological age, do you tend to see that they have more disease states happening for them compared with either same age as chronological or younger than chronological? Does it correlate to diseases?
Yeah, it does. And this is why I mentioned that it seems that biological age is a much more accurate reflection of age-related disease than at actual age. Because somebody, somebody could be 50, but if they've got a biological age of 70, which is what some people have, they are going to get the onset of the classic age-related diseases much earlier, as opposed to someone who's 50 and who's got a biological age of 30. That is not going to happen. And in that case, that age of 50 becomes irrelevant. It's all about the biological age and the health of our cells on the inside.
So are there any downside to trying to intervene in, the good news is if you live a long life, you're going to age, right? Like you want to age, you just don't want to get old. So are there any downsides aimed at or associated with trying to reduce your biological age or slowing aging?
I think, the key thing here is looking at the difference between your lifespan and your health span. So modern society, if there is one great thing it's given us, is these long lifespans. But unfortunately, we're not living these lives in good health. We only have a particular portion of our lives that we're actually healthy, and this is called our health span. And to put it into perspective, for a woman in the UK, her lifespan is expected to be 83 years, but her health span is only expected to be 64 years, which is huge.
19 years. So 19 years of ill health before you just die after being sick.
So that is having multiple age-related chronic diseases. Yeah. So basically, by age 64, my daughter, both of us would be expected, if nothing changes, to get to 64 and have multiple age-related health conditions.
That's pretty depressing, Nichola.
It's very depressing, isn't it? But this is exactly what all of this science is trying to change, because what we know is that our biological age is linked to that age at which we get the onset of these diseases. So if our biological age is lower, that health span gets extended out. So those wonderful 83 years that we've now been given, thanks to modern healthcare and sanitation, etc., we can actually live much better. And maybe we'll get to age 80 in good health and independent, fulfilled lives, rather than being, unfortunately, quite miserable with multiple age-related diseases and not being able to function. So that really is the goal.
Okay, so if I were a listener, because I'm a listener, I'm listening to you, the first thing that I would be asking is, okay, what can I do to decrease my biological age naturally? What are the things people can do?
So the good news is that although a lot of people try to blame their genes when it comes to aging, actually only about 20% of the way we age is related to our genetics. Most of it is our lifestyle. And I always think it always sounds a little bit boring when I give this advice, but it's many of the things that we've heard and we know are either good or bad for us. It's all our lifestyle. It plays such a huge impact in our biological age. So when you are looking at anything that is damaging to the body, so, the classic drinking excessive alcohol, smoking, sunburn, all of these things will be increasing your biological age because they are damaging at the cellular level, they're changing the gene expression, things like that. On the flip side, you have all of the things that are promoting cellular health. Exercise is known to decrease biological age. The diet that you eat, following a diet that is anti-inflammatory, is not full of inflammatory foods, not a beige diet, but rather a diet that is full of lots of different plant materials. So this doesn't mean becoming vegan, but it does mean that you need to increase the number of plants that you eat. And it's been shown that eating around 30 different plant molecules, so this is not just fruit and vegetable, this is herbs, spices, nuts, anything from plants essentially, is shown to reverse that biological age as well.
30 in a week or 30 in a day, or like what's the...
In a week.
In a week. Okay. So I know Deanna Minnick talks about 50 different foods in a week. So you're similar, you're like 30 different plants. So I call it being plant focused. You're not only plants, but plant committed. Like you're leaning towards it.
Yeah, because plants have such a huge range of phytochemicals, nutrients in them. And this was a huge awakening that I had in my background working in drug development, was that there were so many molecules that we were testing that worked better than traditional drugs that were actually from plants. They were things that were found in fruit and, teas, and they were often outperforming some of the classic drugs, which was crazy. But when you think of it, your body doesn't really know what's a drug, what's a nutrient, what's a supplement. We kind of are socially, ingrained in us that actually only a drug can help. But there's a lot of very, very powerful compounds in plants. So it's no surprise that having a diet rich in plants, or a plant-focused diet, does actually help to improve cellular health.
Okay, what else?
The other things that are very good in terms of promoting cellular health, especially anything natural, not supplements, things like that, or lifestyle, are things that actually put your body under a little bit of stress. Now, when I talk about this, I don't mean psychological stress. We know that psychological stress is not good. It's pro-inflammatory. It's inducing a cortisol state that's not good for anything, and it increases your biological age. We know that, and we see that in studies. But the type of stress I'm talking about is little bits of, for example, energy stress. So if you are doing something like intermittent fasting, or you are looking at in high intensity interval training with short bursts of really intense stress on your cells, what that does in your body, in your cells, is it triggers basically an energy alarm bell. And this energy sensor in the cell is something called AMPK, but we'll just call it the energy alarm. And it basically says to your cells, oh my goodness, we are not in a comfortable state. We do not have energy coming in. We don't have food. We need to survive this period of stress. And what it does is it then switches on many beneficial pathways that are designed to be conservative. So instead of being wasteful, the cell is now repairing damage. It's now recycling damaged proteins and reusing some of the parts. It's doing everything it can to restore and repair. And all of these pathways that are beneficial are actually all the time sat inside of us. But our modern lives don't actually let them be switched on, because our modern lives are generally saying, well, let's not overexert ourselves. Let's sit all day. Let's eat every 2 hours. Let's have a snack. Let's make sure we have breakfast. And although these really beneficial pathways are sitting there that are very good for our cellular health, they just don't get switched on. So this little bit of energy stress can actually activate these pathways that promote cellular health and reverse biological age.
So in the course of someone's day, what would that look like? What would they actually have to do?
So fasting, in terms of fasting, it varies. Men and women need to fast differently. The general consensus is that men need a bit longer to activate some of these pathways than women do. But some of it's pretty simple. Say for you and I as women, even just going 12 hours without eating can activate some of these pathways. And that's as simple as, having your evening meal a bit earlier, or having your breakfast a bit later. And then the majority of this fasting is getting activated while you're asleep. So it doesn't really need much change to our routine. In terms of exercise, we know that this high intensity interval training, so short bursts where you're really struggling to keep it going. This is like a sprint. This is really high intensity, is incredibly beneficial. On the other hand, we also know that more very low impact, like zone 2 training, where it's very manageable, power walking, something like that, is also very good for our cells in terms of conditioning our mitochondria, our energy powerhouses in our cells, to be able to be more efficient, which again promotes cellular health.
Oh my God. Okay, this is fascinating. Okay, so I feel like we've touched the surface, and I'm assuming that people are going to want to follow you, find out more about you. Where can people get in touch, find out more about you, and follow you?
Yeah, so I do a lot on Instagram mostly. So not just about NAD, but about all aspects of aging and cellular aging. And my Instagram handle is just my name at Dr. Nichola Conlon. And if anyone wants to know a bit more about our dietary supplement, my company is called Nuchido, Nuchido. And again, you can find us at nuchido.com or on Instagram. And a major passion for both me and the company is not just products, but it's education and really helping people to understand some of the science behind all of these longevity things and how we can implement it into our life. So we do a lot of education and blog posts and just if anyone wants to learn, definitely head to one of our pages.
I think this is great. Okay, listeners, you got it from the source, Dr. Nichola Conlon. She is the founder of Nuchido and also a molecular biologist. And we just talked about NAD. So follow her, like her, do all of that. And then, Nichola, thank you for being here. This was really cool. And now I'm starting to think about okay, I don't do this, I don't do that, I don't drink, I don't smoke, but I have stress. So I'm like, okay, I think I need to move more and stress less. So thank you for this, because it's always good as a reminder, right? Like, how do we healthfully age and improve our health span? So thank you. Thank you for being here.
You're welcome. Thank you for having me.
My pleasure. And thanks to listeners for joining us for another episode of the Feel Freaking Amazing podcast.
Were you inspired and empowered today?
Don't forget to follow so we can help you keep transforming your health.
Until next time.